The purpose of this video is to demonstrate how to wire a maglock and brake glass with brake glass detection. We will also examine how to wire a door contact and a push to release button. A maglock is a fail-safe device as opposed to a fail-secure. Fail-safe means the maglock requires power to remain locked. Fail-secure means that the device remains locked if power is lost. So, in order to wire the maglock, we need to take 12 volts from the 12 volt output and wire it into common on the main relay. We then have to wire from normally closed on our relay to common on our brake glass unit. Then from the normally closed on the brake glass unit to the positive of the maglock. Lastly, to complete the circuit, we have to connect the negative of the lock back to OV on the PSU. In its normal state, there is continuity or a connection between common and normally closed. When the relay is energized, it swaps state and the armature connects common and normally open, breaking the connection between common and normally closed. The brake glass uses the same principle. Let's look at an analogy and compare this to a simple water system to simplify the concept. Okay, so in this instance the ACT365 relay is currently in its normally closed state, so we can see the current or the water flowing in from common down into normally closed, and then from normally closed it connects to common of the brake glass, and you can see the brake glass is in a normally closed position as well, so the current or the water flows from common into normally closed. But say for example now the state of the ACT365 relay changes, you can see now the current comes in and it flows into normally open, so that's connected to nothing. This breaks the circuit and water or the current can no longer flow down into the maglock, causing it to de-energize, hence causing the door to open. So the same can happen too if someone doesn't use the 365 and there's an emergency and they push through the brake glass and the ACT365 relay is in a normally closed state. However, the brake glass changes state. You can see once more, instead of going from common into normally closed, it now flows from common into normally open, which is connected to nothing. So if either one of these relays changes state, it breaks power to the maglock, causing it to de-energize and open. So hopefully this water analogy makes the concept of wiring two relays in series a little bit more clearer. We will now look at wiring the brake glass detection. This is very useful for triggering the auxiliary relay to fire a sounder or a strobe in the event the brake glass is pushed. Brake glass detection input is looking for a continual 0 volts. When the brake glass breaks this input, the door status will report, and if configured, the aux relay will fire. So to wire, we need to bring a 0 volts into the common terminal of the brake glass, and then coming out of the normally closed, we need to bring this around and wire it into brake glass detection input. And that's all that is required to wire the brake glass detection. The last part of this video looks at wiring a door contact and a push to exit button. Let's look at the push to exit first. The PB input needs an O volts on it to unlock the door. The PB should be a push to make as opposed a push to break. On the PB switch you should wire O volts into your common and coming out of the normally open terminal into PB. To wire a door contact, the DC input is looking for a continual O volts. Once receiving that O volts, it knows the door is closed. Once the DC input loses that signal, it knows the door is in an open state. Hence, on your door contact, the common should be wired to O volts and the normally closed to DC. This concludes our tutorial on maglocks, brake glasses, door contacts and push buttons.